Let's briefly do a practice example of a company using ABC in practice. For this example, we have High Challenge Company. They make two products. For the sake of keeping it simple, we'll just do two. Obviously, most companies have more than two products, but if you can do this for two, you can do it for several. Their two products are touring bicycles and mountain bicycles. They've looked at all of the activities they have that cause them to incur indirect costs, which is hard to trace to either of these two different types of bikes. And from that whole mountain of activities they had, they believe that four cause the majority of these indirect costs to be incurred. They are purchasing materials, setting up machines for production, inspecting products when they are completed, and operating the machines in the process of making and machining these touring bikes and mountain bikes. And with those four activities identified, High Challenge is going to set up a cost pool for each individual activity and find different ways to take the costs out of the respective pools and putting them into their touring bikes and mountain bikes to try to fairly determine what amount of indirect costs each of these two different product models is causing the company to incur. The company's accountants in this example have estimated the activity level and total cost for each of these four activities as such. They estimate that they will have to purchase 10,000 pieces of material at a budgeted cost of $20,000 to make these bikes. So this is the salaries of our purchasers and the workers in the storage facility that have to move all of this raw material around. They also estimate that it's going to require 40 setups at a cost of $80,000 to make sure that our machines are cranking out parts for these bicycles in accordance to the way we expect them to be, quality control, if you will. What goes into the cost of setups, paying the laborers that go into there, any new parts or lubricants, etc., that you need in the setup process to keep your machines operating in an effective manner. So all those costs are going to total up to $80,000 for a total of 40 setups. They estimate it's going to take 400 inspection hours in total to look over all of the bikes that they make, be they mountain or touring. And in total, they're going to have to pay $40,000 in inspector salaries to properly inspect the goods they are producing. And then lastly, they're going to run machines for 2,000 machine hours during the period. And in total, they're going to incur $60,000 of costs to do so. And this could be things like the depreciation, repairs and maintenance, utility costs, if that goes in there, like all of those costs are going to total up to $60,000 for their machining activity for the period. And if we have $20,000 from purchasing and $80,000 from setups and $40,000 from inspection and $60,000 from machining, that totals up to $200,000 worth of indirect costs or overhead, which is going to need to be allocated out amongst these two different products that ABC makes. Well, what do we do here? It's the same exact concept that we had for a single driver system. Instead of coming up with one universal predetermined overhead allocation rate, we're going to find a rate for each individual pool. And our first pool is for material purchases. They need to determine a driver that's going to get the cost out of those pools fairly into the cost of the different products that we're making. And they decided their best driver here is the quantity of materials, and it makes sense. The more units of material that a product requires, well, the more you have to pay your purchasing people in salaries, etc., to acquire it. So direct material quantity is going to be their driver for that activity. Machine setups, what would be a good driver? The number of setups you have to do. Product inspections, how many hours you're going to have to spend inspecting those products. Seems like a fair way to get costs out of our product inspection pool and into our two different types of bicycles. And running machines, or machining if you will, what's the best one there? Typically, if anything is machine-based manufacturing, your best driver is going to be machine hours used to make a particular product. So what are our budgeted costs for each activity? Well, for materials, it was $20,000. For setups, it was $80,000. For inspections, it was $40,000. And for machining, it was $60,000, leading to a total of $200,000 of indirect costs we need to get out of their respective pools and into the cost of these goods that we are producing. What is the budgeted quantity of the driver in total across all products? Well, for purchasing, their driver is direct material quantity, and we estimated over here that we're going to have to buy 10,000 pieces of material during the period. For setups, their driver was the number of setups. They're estimating it's going to take 40 setups for production during the period. For inspection hours, they estimate, or for inspecting, they're using inspection hours as their driver, and they estimated it was going to take 400 inspection hours. And For machining, they're going to use machine hours as their driver, and they estimated it was going to take 2,000 machine hours. Well, now all we need to do to come up with a predetermined overhead allocation rate for each activity is divide the budgeted cost of that activity by the budgeted quantity of the driver. We have to spread $20,000 out amongst the purchase of 10,000 units of material. That means that our allocation rate should be $2 per piece purchased. For setups, if we have to spread $80,000 out amongst 40 setups, that means that each time a product requires us to do a machine setup, we should be allocating $2,000 of indirect costs to that product's total cost. For inspections, it's $40,000 spread out amongst 400 inspection hours. That's going to come out to a rate of $100 per inspection hour. And for machining, that's $60,000 that needs to be spread out amongst 2,000 machine hours. And that's going to come out to a predetermined overhead allocation rate for our machining activity of $30 per machine hour. So for the next 8-hour shift, we're making touring bikes, 8 times 30. $240 should be assigned in indirect costs to the touring bike related to machining. And now that we have a driver for each of our different activities, if we know what quantity of that driver went into each of our 2 respective product lines, we know how to get those costs out of each activity's pool and into those products. So for this month of January, High Challenge has 2 different models they're making, touring and mountain. The first activity was material purchases, and we are going to estimate that it's going to take 6,000 pieces that we have to buy to produce touring bikes during the period, and 4,000 pieces for mountain bikes. For setups, the touring bike is going to require us to do 10 machine setups, while the mountain bike, much more intricate with all of its gears, etc., is going to take 30 setups. Both product lines that we have are going to require 200 hours to inspect, and touring bikes, maybe we're making a lot more of them, requires a significantly greater amount of machine hours during the period. We're estimating it's going to take 1,500 machine hours to make touring bikes and only 500 machine hours to make mountain bikes. So now that we have the amount of the activity, the quantity of the activity, if you will, for each of our different product lines, and we have a predetermined overhead allocation rate for each of our different activities, we can just take how much of a driver each product's going to take, multiply it by that rate, and that's how much cost we're going to assign to that particular model. So for the touring bikes, material purchases, they are planning on purchasing 6,000 pieces of material, and our predetermined overhead allocation rate is $2 per piece, so 6,000 times 2 means that the touring bikes, according to our methodology, are causing us to incur $12,000 of indirect costs during the period for the activity of buying the materials they need for production. For machine setups, that particular model is going to require 10 setups. Our allocation rate is $2,000 per setup, so 10 times 2,000 is 20 grand. We're going to spend $20,000 in costs making sure that our machines are properly set up for fabrication in the future of producing touring bikes. For product inspection, it's going to take 20 hours to inspect all of the touring bikes that we make at a rate of $100 per inspection hour. We've got some well-paid inspectors up in there. 20 times 100 is another 20,000. And then for machining, it's going to take 1,500 machine hours to create all of those touring bikes. We're allocating at a rate of $30 machine hour, so 1,500 times 30 means $45,000 worth of indirect costs are being incurred because we had to machine and manufacture touring bikes. And that totals up to $12,000 plus $20,000 plus $20,000 plus $45,000. $97,000 of indirect costs, which are being caused by the production of touring bikes across our 4 prominent activities. For mountain bikes, same theory. We're going to take the quantity of the driver for each activity located in this column and multiply it by our predetermined overhead allocation rate for that particular activity to figure out what amount of indirect costs we should be assigning to that product. So for mountain bikes, we're purchasing 4,000 pieces of material at our $2 per piece allocation rate. $8,000 of indirect costs are going to go into mountain bikes for purchasing. For machine setups, it's 30 setups at $2,000 per setup. 30 times 2,000 is $60,000 worth of costs are going to go into machine setups. For product inspections, that is 20 hours it's going to take to inspect at a predetermined overhead allocation rate of $100 per hour. $20,000 in indirect costs getting assigned to the mountain bikes for that activity. And then the mountain bikes take significantly less machine time. It only takes 500 hours to machine all of the mountain bikes that we're going to make during the period. So at a rate of $30 per machine hour, that's $15,000 that should be assigned to mountain bikes. So what is the total overhead that we're going to assign to mountain bikes using this ABC system? 8,000 plus 60,000 plus 20,000 plus 15,000 is 103 grand. So ABC's $200,000 of indirect costs they have to spread out of all of their pools combined got spread out as 97,000 to touring bikes and 103,000 to mountain bikes. Pretty fair split here. Not perfect, but pretty close. Why would we choose to use this system? Because there are times when you can't use a single system in a fair manner. Let's take those same numbers we've been working with here and say, instead of having 4 different pools for the different activities we have which are causing us to incur indirect costs, we just have one pool where we capture all indirect costs. And because, having to cut all of the parts for these bikes is probably the biggest thing that's causing us to incur indirect costs, let's just use machine hours as our driver. Well, what do we have for information here? We have $200,000 worth of overhead expenditures that need to be spread out amongst all of our different products. We're using machine hours. If we were just using a one single simple pool to do this, we have a total quantity of that driver of 1,500 hours for touring bikes, 2,000 for mountain bikes. 500 for mountain bikes. That's 2,000 in total. Getting ahead of myself. So 200,000 divided by 2,000 means that our allocation rate should be $100 per machine hour if we're putting all of the costs into one pool and using one driver to get all of those costs out of the pool in the different products. How is that going to affect the profitability of our 2 different products, or at least the way we perceive that profitability? Well, the touring bike takes 1,500 hours. At a rate of $100 per hour, if we use a simple system, that's $150,000 worth of overhead that would get assigned to that particular model. The mountain bike only takes 500 hours to manufacture, and it, at a rate of $100 per machine hour, would only have $50,000 of overhead applied to that particular model. Using this simple system right here, the touring bikes look way more expensive than they did when we used ABC system. Why would that be? Because we're only using one driver. Essentially here, because the touring bikes take so many more hours to machine than the mountain bikes do, they're going to have more costs allocated to them. Well, what is our most expensive activity in terms of driver rate? It's setups. And the mountain bike takes way more setups than the touring bike. So using this simple system is basically causing the touring bike to absorb the cost of setups for the mountain bike because it uses more of the driver. Well, why wouldn't you just use setups? Because then you have the opposite problem. If we use just setups as our single driver over here, the mountain bike, which takes so much more, setup time to keep going, would effectively be subsidizing the machine costs of the touring bike. So we don't have a perfect single driver to use here, and therefore the best thing that we can possibly do is get a little more refined, break it down into different activities, and it'll spread it out much more fairly. And if we do that, we see that our overhead is pretty close for both of these models.